Our next presenter, the last for this session, is Joycelyn Lado. Okay, thank you. The floor is yours.
Okay. Hi, I'm Jocelyn Lytle. I'm a first-year master's student under the supervision of Dr. Steve Shirtliff. And today I'll be talking to you about my research, which is called A Methodology for Field-Based Trials to Evaluate Nitrogen Response in Canola, which is termed Modulated On-Farm Surface Response Experiments, or MORS for short. And as you can see, I have both wheat and canola there, but I'll be focusing on the canola. Okay, so then just a brief overview of what I'll be presenting today. Just my introduction, materials and methods, and some preliminary results from just the canola again. Oh my God. Okay, so for introduction, so there's two main current methods for agricultural research, which is small plot randomized complete block design, or RCBDs, and strip trials, which each have their benefits and downfalls. RCBDs require uniform soil conditions, and the field location often alters the results that you get, as well as advanced planning is needed to place the treatments in the correct spots. And strip trials often result in unbalanced data due to the lack of replication, and this can be hard to determine treatment effects due to the large amount of the field that they cover. So the proposed methodology, or the MORS design again, would allow for experimentation to be done on specific producer fields, allow for replication of the treatments, it utilizes precision agricultural techniques, and it systematically applies treatments instead of randomizing them. So my research objectives are to evaluate a field design and use an in-depth statistical analysis framework that can be performed on-farm by producers, which will aid in realistic results for deciding on specific rates of specific crop inputs, as well as to utilize imagery techniques to help determine the crop response to specific agronomic inputs and aid in data collection. So my materials and methods. For this trial, there was a total of 11 treatments, varying from 0 to 310 kilograms per hectare of actual N, which were replicated 20 times across the field for a total of 220 plots in my one site. And there's also a virtual plot design for this trial, as you saw on the first title slide, where there is no pathways between the replications. So this is an example of the plot map. So the white pass is the MORS design, and as you can see, it goes up in order, like 3, 4, 5, and the yellow is just a traditional RCBD. The RCBD is embedded in the MORS design to allow for a more accurate comparison between the two. And this is what it looks like in the field. Okay, so this is just preliminary results from site 1. So there's 2 sites where this was done. The first one is the low nitrogen site. So this site has low nitrogen, obviously, and there's also the under site. So the results I'm mostly showing are from that low nitrogen site, just because they have more dramatic curves given. So as you can see, the left side is when the designs are kept together. The middle is the RCBD only, and the right is the MORS only, which shows similar trend lines between the two. And then this is just a nonlinear model to represent that same data, which very similar trend lines between the designs again. Then just the mean and coefficient variation between the two. For the MORS design, it was hypothesized that it would be or have a lower CV, but as you can see from the graph there, they are pretty similar. Yeah. So then the results I've been showing have mostly just been from yield, but I did do various other data collection points, which also can be compared between them. I took plant counts on all of the plots, as well as an NDVI with a handheld green seeker, biomass, yield, and then total nitrogen from my ground biomass samples. So this is just the Morse only, and then the RCBD only as well. And yes, again, those results that I was showing with the yield, you can, again, go through those same graphs that I was showing previously. And then this is just some of my Site 2 preliminary data just to show that it follows the same pattern as in Site 1. I didn't want to go through all of the same graphs that I previously shown, but... And then my conclusion. So future work, this is done at the Kernan Research Farm right now on small plot, but it is looking to be moved to producer fields and utilize our commercial equipment. Also want to determine the ideal number of replicates for a producer's field, because 20 is a lot. It was a lot of plant counts and a lot of data to gather, but will be really useful with my statistics to run. And this design can be replicated for other agronomic inputs, such as there's phosphorus rate. There's also another part to the trial, which is different fungus rate or fungicide rates. And like I said, this was just preliminary results. I will be doing more statistical analysis on the rest of the trial and the data to further compare the two designs. And I'd like to thank everyone in the Agronomic Crop Research Lab and the field crew and everyone that helped me so far in my 2022 season, and I hope to see what 2023 brings.
Yeah, thank you. So if you have questions, we can take some.
Yeah, thanks very much for the presentation. Some really neat method development. My question is, so going forward to the next stage where you would upscale this to producers' farms, I'm just wondering functionally how would you do that? Would you give them a shape file with spatial information that would automatically dictate these different treatments, or how does that work?
Can you repeat the question? Okay, so moving forward to producer fields, how would we show the same design? So you're kind of getting at?
I guess how do you get them to practically implement that?
Okay. I do not know off the top of my head. That's in the future, I guess, but it depends, I guess, on what they want, like what specific input they're going to be doing. It would be a little bit different than this, but again, I'm not 100% sure, but.
I have a question. You presented CV values, and I don't do field research so much, so I'm kind of confused on why does it matter if you have a really large CV differences? What is it actually showing you, especially comparing between Morris and RCBT? Like, is that talking of, yeah, just.
Okay. Okay, so I showed, figure out my notes, for the CV. So if you have a larger CV, the values are more dispersed around the mean. If you have a smaller one, they're less dispersed, so that the data is more accurate in that frame. So I was mostly trying to see if the Morse design was as accurate. So if they had a similar CV to each other, then I would think that it'd be similar in that aspect, if that makes sense.
Like, if you did this in the field, you can consistently capture all the field variation between Morris and RCB if they have similar CVs. That's what you're.
Yes, basically try to get at that. There needs to be more analysis done, of course, but yes.
Maybe I missed it, but how structurally is this different from a randomized complete block design?
The treatments. Oh, there we go. So pass 1 is the Morris design, like all the way up, and they're not the treatments aren't randomized. They just go in order, whereas pass 2 they are randomized. Yeah.
Any other questions? Yeah, thank you for your attention. This was our last session, our last speech for this session. We will have a 15 minutes break. Then we will meet here at 11 for the next session on fertilizer management. Thank you.